Okay, today's lesson, we're going to find the zeros of a quadratic equation by factoring. So yesterday's lesson, we talked about factoring. We did a bunch of problems involving factoring quadratics. So we may have had something, let's say, like this, where basically the way I looked at it is we call it like a backwards FOIL. We have to recognize that this is a trinomial, meaning it's got a squared term, then it has an x term, and then just a constant or a number. So there are three terms, so we call it a trinomial. 1, 2, 3. Okay? And the trick is to recognize that that came from one of these guys, where this is x times x times x makes x squared right there. Okay, and then you have to ask yourself, to put numbers here, we need two numbers that will multiply to equal -7. And the only numbers that multiply to 7, period, are 1 and 7. So you could put a 1 and a 7 here. You could go either way with that. And then you have to ask yourself, how am I going to make those two numbers add up to that 6 right there? We need +6. So we want the bigger number here to be positive. So we want +7 minus 1. And this could have either been x minus 1, x plus 7. You could have wrote it x plus 7, x minus 1. Either one of those answers would be fine. That's just factoring. That is not today's lesson. That was the old lesson. But the new lesson is going to build off of that. So here's the same exact quadratic right here, but now instead of it just being a quadratic expression, we're going to call it a function. We're going to say f of x equals x squared plus 6x minus 7. And the question is now not just to factor it, but to find the zeros. Find the zeros of this function. And all that means is find out what x values you could put in here to make the function equal 0. Or to really say it real simple, 0 equals x squared plus 6x minus 7. And we need to now solve that equation. Well, we're using the exact same skills as we did before. We're going to factor this. We're going to factor x squared plus 6x minus 7, and you'll see why in a second. So it's the same exact one I did. So it's x, I think I had x minus 1, x plus 7. But now it equals 0. And the reason we factor this is because any time you have two things multiplied together, now this is this times this, where it used to just be a bunch of stuff here. It was three things. It was this plus this plus this. Now it's just this thing times this thing. And we know that those two things multiplied together equal 0. Well, there's a rule, it's kind of a common sense rule, that says that anytime any two numbers multiply together to equal 0, the only way for that to happen is if A equals 0 or B equals 0. If you just think about whenever you have two numbers and you're multiplying them together, and it already says they equal 0, well, isn't it kind of common sense that one of those things must have been a 0? The only way to multiply two numbers together to get 0 is for one of them to be 0, or the other one. So that's what this says right here. How does that help us? Because now we know, let's go back, we're starting from here now, okay? And we know that that means that x minus 1 equals 0, or x plus 7 must equal 0. And now we're solving super basic little equations. We know that x equals 1, x equals -7. The question said, find the zeros. There it is right there. And we found them. It's right there. Those are the two answers to that problem. Almost the same thing, but now you're actually a little more meaningful. You're actually solving an equation now. You're figuring out what numbers you could plug in for x. And when you plug them in, so example 1, if you put a 1 in here, you get 1 squared, which is 1, plus 6 times 1, which is 6. So 1 plus 6 is 7. 7 minus 7, 0. We figured out that if you plug a 1 into here, you will spit out 0. And the same would work if you put a -7 in there. You can check that yourself if you'd like. I'll do a couple more examples for you. They're going to get pretty repetitive. There's not too much going on here other than your factoring skills from the last lesson and now simply just setting them equal to 0. So if I want to find the zeros in this problem, I'm going to set f of x equal to 0 because I'm trying to figure out what makes this function equal 0. And then we're going to factor. If you ever want to solve a squared equation, one of the easiest ways to do this, and it works quite a bit, is to factor this thing. And so we will do that right now. Notice that there is a 2 that's common to the 2, the 4, and the 6 in that problem. So we're just going to factor out a GCF. I call this backwards distributive property. And we end up with this. And at this point, that 2 right here isn't really going to matter at all in this problem anymore. In fact, we could just divide by 2 right now, both sides of the equation, if we want, and we still have 0 over here, and now we just have this. I'll show you some different ways to handle that on a different problem, but for now, I factored out the 2 right here, the GCF, and then it just kind of goes away because if I divide by 2, I still have 0 here, and that crosses out, so I'm just left with that. Now we factor. X makes x squared. We need 3. So 1 and 3 are the only ways to multiply two numbers together to make 3. We have x times x equals x squared. We have 1 times 3 equals 3. And now we have to make sure we put the correct signs here and here so that we end up with positive 2 when we do our outsides and our insides. And we need the bigger number to be positive and the smaller number to be negative. And we get this. And then finally, x minus 1 equals 0. X plus 3 equals 0, x equals 1, x equals -3. There's those two answers again. Whatever the power of an equation is, its highest power, if you look up to the top here, I'm pointing to the fact that that's a squared power. That means it has 2 answers. And we got our 2 answers there. All right, let's take it up a notch here. In this problem, we're in the same boat. We're not doing anything too different. We still says find the zeros. So we're going to set this function, f of x, we're going to set that equal to 0. And then we just have to solve our equation. So our first step is always just to set that equal to 0 because we're trying to find the zeros. Now, this one's a little different because there is this 3 right here. 3 is not divisible, does not divide into the 14 and the 16. So we can't just do what I did last time and get rid of this 3. So we have to go straight to factoring. So we're gonna go straight to here. And the only difference, and we just did a lot of these, the other day too, is we can't just put x and x. We're going to have to put 3x here and x here. That's the only possibility to make 3x squared is 3x times x makes 3x squared. So we're good to go there. We know that has to go there. 16 is the two numbers that go here and here have to multiply to make 16. Well, there are some choices for that. You have 1 times 16, and you have 4 times 4, you have 2 times 8, lots of choices. And let's just try something. I mean, you could sit here and try to just mentally stare at this and put these numbers in there and try it in your head, or you could just put some numbers in there and see what happens. I think I will, as I said in class a lot, I'm going to purposely be wrong. I want you to see what it takes to do trial and error on these. So for example, if I put a 4 and a 4 in there, okay, that does make 16. 4 times 4 is 16. But we need to make this and this add up to be negative 14. Or just any, don't even worry about the negative right now, 14, period. Is there a way for 12, 3 times 4 is 12, and 4 to be 14? Is there any way to either add or subtract so that 12, either plus or subtracting 4, makes 14? Of course, the answer to that is no. So it's not 4 and 4. So we can kind of just cross that out. It's not 4 and 4. So let's try again. I'm just going to rewrite it right here. Okay, so I'm back to the beginning here. 3x and x. So I could try the 1 and the 16. I could just put those in there, 1 and 16, and I'm already feeling that that is not going to work for us, but just let me show you. We'll show you. So this is obviously not going to work because you would have 48 and 1. Don't forget, we're trying to get 14 in the middle here. Well, we know that's 16. We have that. We know this is 3x squared. We have that. But we have to get this 14 in the middle. Well, 48, 3 times 16 is 48, and a 1 are never going to combine to be 14. So that's not it. Let's try it again. Let's put the 1 here and the 16 here, because that is different. Now we have 3 and 16. And I don't see any way to add 3 plus 16. That's 19. That's not 14. If I subtracted 16 and 3, I'd get 13. What does that mean? It means I'm done with 1 and 16. It's not any of those. It has to be 2 and 8. So we'll do it again. And let me go ahead and let me be right this time. So let's be right. How about we go 2 here, 8 here. Put a 2 and an 8 there. Look what happens. You have 6 and 8. 6x and 8x. Is there any way to make 6's and 8's add up to 14? Yes. And then the only thing left to do now is think about the signs. We have we need positive 16 right here. And therefore, these two signs that we're going to put there have to be the same sign. It's either plus plus, because positive times a positive would equal positive, or it's minus minus, because negative times negative would also be positive. But if we were to put plus plus here, the whole problem would foil out to be all positive. If you put pluses everywhere, you're going to get pluses everywhere. But we know we need a negative 14 here. So that's what I'm saying. Okay, and we know it's supposed to equal 0. It's supposed to be 0 the whole way through here. Okay, and we factored it. Okay, this right here, if you were to FOIL that out, it will equal that thing up here. Why do I want to do this? Because whenever two things multiply together to equal 0, then 3x minus 8 equals 0, x minus 2 equals 0. And this is going to be 3x equals 8, x equals 8 over 3, and this one is just 2. Pretty cool. You would never, I mean, think about this. Look at this original problem up here. How in the world would you ever figure out that if you put an 8/3, 8 over 3 into x, and do all the squaring and the multiplying by 3 and the times 14 and all that, it's going to equal 0. These also aren't the most fun questions to check, especially when you get fractions like that. You almost just need to trust yourself that you did it right. It's tough to go in there and want to square fractions and multiply them by 3 and all that stuff. So I think that's enough for the video. You have 4 examples. It kind of starts extra simple. I've reviewed, factoring a little bit with you, but that was kind of the old lesson. Today, really, the only difference is when we're done factoring, we set the two individual pieces equal to 0. It's kind of the whole idea of factoring, is so that you could solve equations like this. Hope that helped. Good luck with the homework. See you soon.